video is from Hillsar English Medium School.
Hello students, we have started with the Science Standard 8, Chapter 2 is Matter Around a Sphere. In first part of this lesson, we have discussed about matter, different types of matter, mixture and solution. Let us revise this with the help of video.
What do air, milk, soil and brass have in common? Didn't get it? They are all mixtures. Air is a mixture of nitrogen, oxygen and many other gases. Milk is a mixture of water, fats, proteins like casein and carbohydrates like lactose and so on. Similarly, soil is a mixture of many things and brass is a mixture, or more specifically, an alloy of copper and zinc. Most of the substances that we come across in our daily life are mixtures of two or more pure substances. We know that a mixture is not a chemical compound. In all of these examples, the different components in the mixture are not chemically combined. That is, they do not chemically react with each other to form compounds. There is one interesting characteristic of a mixture. Its properties depend on the proportion of the different components in it. To understand this better, let's make 2 cups of tea. Let's say we've added 1 sugar cube, half a cup of milk and some tea leaves in this cup, and 2 sugar cubes, 3/4 cup of milk and some tea leaves in this one. Since in the second cup we've added more milk, it'll be lighter in color. The addition of 1 extra sugar cube will also make it taste sweeter. Even though we've put the same components in both the cups of tea, there is a difference in their properties. So we see that the properties of a mixture depend on its composition. But more appropriately, we'd refer to tea as a solution instead of a mixture, right? Because tea is a liquid and liquid mixtures are called solutions. Is it so? Do solution and a mixture refer to the same thing? Partially, yes. In this video and a few upcoming ones, we'll learn about solutions, which are an important type of mixture. In front of you, there are 3 glasses of water. In one of them, we've added mud. In the other, we've added salt. And in the third, we've added sugar. Can you identify which glass has which mixture just by looking at them? Yes, you can easily identify the muddy water. But what about the other 2? We can't differentiate between the other 2 as both the mixtures look just like water. This is because in these 2 cases, we cannot see the dissolved salt or the sugar particles with our naked eyes. The salt and the sugar particles are evenly distributed in water. Whereas in the glass with the mud and water, we are easily able to see the mud particles suspended and settled in the glass. So, we can see that there are 2 types of mixtures. In the first mixture, its composition is not uniform, and its components are in different phases. That is, you're able to see the different components separately. So this type of a mixture, which has non-uniform composition and varying properties, is called a heterogeneous mixture. And in the second and the third mixtures, their composition is uniform throughout. And its components are in a single phase. That is, we cannot separately see the individual components. So this type of a mixture in which its composition and properties are uniform throughout is called a homogeneous mixture. For example, in a bowl full of mixed nuts, it's possible to identify the different nuts in the bowl. And the composition of the mixture is not uniform. So, it's a heterogeneous mixture. Can you tell me if a block of steel is a heterogeneous or a homogeneous mixture? Steel is a mixture of mainly iron and carbon along with some other elements. But these different components are not visible to our naked eyes. And its composition looks uniform throughout the mixture. So, it's a homogeneous mixture. Now, these types of homogeneous mixtures are called solutions. That is, a solution is a homogeneous mixture of 2 or more components. So, here the mixture of salt and water, the mixture of sugar and water, and steel are all solutions. But wait, as we saw before, we usually think that solutions are always in liquid state. But here we mentioned that steel is a solution. Yes, solutions need not always be in a liquid state. They can be in any of the three states of matter, that is gas, liquid or solid. For example, air, which is a mixture of oxygen, nitrogen and other gases. Another one is carbon dioxide in the soft drinks, where the gas is dissolved in the liquid. So a solution can be in any of the three states of matter. Now here's a question for you. We know that the salt dissolves in water to form a solution. Does the same happen when we put salt in oil? No, right? Salt and oil don't mix. Why is it so? Think about it. In the upcoming lessons, we're going to understand this. We will see how a solution is formed, how their properties differ from their components, and so on. To stay updated and to keep learning such interesting things, do subscribe to our channel.
Now let us move towards the properties of a solution. Solution, it is a homogeneous mixture. मतलब क्या? Whatever the contents are there, they are completely mixed such a way that we cannot identify or separate each of them. जितने भी कंपोनेंट्स हैं मिक्सचर में या फिर सॉल्यूशन, वो हम सेपरेट नहीं कर सकते, सेपरेट वो नहीं दिखते. द पार्टिकल्स ऑफ अ सॉल्यूशन आर स्मॉलर देन 1 नैनोमीटर. कितना है? 1 नैनोमीटर मतलब 10⁻⁹ पार्ट ऑफ मीटर इन डायमीटर. इतना डायमीटर होता है उसका. सो दे कैन नॉट बी सीन बाय नेक्ड आई. सो वी कैन नॉट सी एज इट इज. Because of very small particle size, they do not scatter a beam of light passing through the solution. अगर solution से अगर हमने light pass भी किया तो scattering जो होता है ना वो नहीं होता. So the path of the light is not visible in the solution. The solute particles cannot be separated from the mixture by the process of filtration. We know how the solution is made. Solution is made by adding solute into the solvent. ये जो solute particles, we cannot separate it from the solvent just through by filtration process. Filtration से भी वो separate नहीं होता. And also these solute particles, they do not settle down when left undisturbed. अगर हमने solution ऐसे ही रख दिया for some time, the solute particles जो है उसमें वो settle down नहीं होते, नीचे saturate नहीं हो जाते. So that is what we call that solution is stable.
Properties of solution. A solution is a homogeneous mixture. The particles of a solution are smaller than 1 nanometer in diameter, so they cannot be seen by the naked eye. Because of very small particle size, they do not scatter a beam of light passing through the solution. So the path of the light is not visible in a solution. The solute particles cannot be separated from the mixture by process of filtration. The solute particles do not settle down when left undisturbed. That is, a solution is stable.
Let us move towards the concentration of solution. We can make a solution of different concentration by changing the amount of solute and solvent. If we vary that, the concentration of solution may vary. अलग अलग concentration, अलग अलग quantity में अगर solute ले solvent में add करें तो वो different concentration solution बन जाता है. Depending upon the amount of solute present in the solution, it can be called a dilute, concentrated और saturated. अगर ज़्यादा quantity में solute है तो उसे हम saturated solution बोलेंगे, उससे थोड़े कम quantity में तो concentrated बोलेंगे, और बहुत ही कम solute है तो we call it as diluted solution. So in activity 1.2.2, a solution obtained by the group A is a diluted as compared to the obtained by group B. 2.2 में activity जो है उसमें group A को जो solution है वो diluted है क्योंकि उसमें कम solute डाला था compared to group B. Now let us move to the activity 2.3. यहाँ पे क्या करना है? We have to take 50 ml approximately water into separate beaker. दो beaker में हमें 50 ml water लेना है. Then add salt in one beaker. एक beaker में salt डालना है और दूसरे beaker में sugar डालना है, और we can take barium chloride in the second beaker with the continuous stirring. Stirring से क्या कहता है? मतलब आपको continuously हिलाना है. so that what is the salt or the barium chloride or the sugar we have added get completely dissolved in the water. When no more solid can be dissolved, मतलब इतना हमें ऐड करना है कि when we add at the starting it get completely dissolved till a point reach when the और ज़्यादा हम salt डालें sugar डालें तो वो dissolve हो ही ना, वैसे ही रहे. Then after that we have to heat that content, heat करना है उसे. So the temperature rises by 5 degrees Celsius, उसका temperature 5 डिग्री से बनाना है. And then start adding the solute again. हम क्या होगा जब temperature बढ़ेगा, whatever the solute we add it get dissolved easily into that hot solution. Is the amount of salt and the sugar or the barium chloride that can be dissolved in the water at the given temperature. The same जैसे कि एक टेम्परेचर में जो सॉल्ट डिज़ोल्व होता है उतना ही शुगर डिज़ोल्व हो रहा है क्या एट एनी पर्टिकुलर टेम्परेचर. एक पर्टिकुलर टेम्परेचर लो 25 हो लो या 30 डिग्री लो, अ सोल्यूशन दैट हैज डिज़ोल्व एज मच सोल्यूट एज इट इज़ कैपेबल ऑफ डिज़ोल्विंग. एक 25 रूम टेम्परेचर में क्या करता है, एक पर्टिकुलर अमाउंट ऑफ जो सोल्यूट है उसमें डिज़ोल्व हो जाएगा, जितना पॉसिबल है उसको उतना वो डिज़ोल्व कर लेगा. सो दैट वी कॉल इट एज सैचुरेटेड सोल्यूशन. मतलब ऐसा सोल्यूशन कि उसमें अगर हम एक थोड़ा सा पिंच भी और ऐड कर दे सॉल्ट या फिर शुगर, इट कैन नॉट डिज़ोल्व. इन अदर वर्ड when no more solute can be dissolved in a solution at a given temperature, it is called saturated solution. So what is saturated solution? जिसमें हमने और भी कुछ solute add किया तो it cannot dissolve. So the amount of solute present in the saturated solution at the temperature it exceeds its solubility. मतलब उसकी अभी solubility बाकी है ही नहीं, जितना भी soluble होना था वो हो चुका. Now the next pinch is the extra one.
What are we going to do today?
I want to test whether a glass of water can dissolve any amount of sugar.
What's there to check? Quite a lot of sugar can be dissolved in a glass of water.
I don't think so.
Okay then, go ahead and test it. We shall find out the truth.
This glass contains water, while this bowl has sugar.
Only this much sugar. Bring some more.
Let this much sugar get dissolved in the water first. Then I will bring some more.
Okay, let's start.
Put a spoonful of sugar into the water, miss.
See, a spoonful of sugar completely dissolved in a glass of water.
Wait, we shall add more sugar now. Miss, keep adding more sugar in the glass.
Oh no! The sugar is not dissolving in the water anymore.
Exactly. This is what I was telling you.
So it means that if we take fixed quantity of water, only a fixed quantity of sugar can be dissolved in it.
Not just sugar. Any dissolving substance will have a fixed quantity that will dissolve in a given fixed quantity of water.
That means things like salt, baking soda, etc. will also have a fixed quantity that dissolve in water.
Yes, if you want, shall we try this test with some other dissolvable substance?
Hey, if we do all the work, what will our friends do then? Friends, try this test with the other dissolvable substance and do tell us your experiences in the comment section below.
Okay, now tell me, what would you call this solution when sugar cannot be dissolved anymore in the water?
When sugar dissolved in water, a solution was created. So what else would you call it other than a solution?
It will be a solution when any substance dissolve in it. But when that substance cannot dissolve further, then it is known as saturated solution.
Saturated solution. This means that when no more sugar can be dissolved in a glass of water, the solution is now known as saturated solution.
Correct.
Now let us move further. If the amount of solute contains in a solution is less than the saturated level, मतलब क्या, saturated level में maximum जो dissolve हो सकता है, उससे अगर solute कम होगा तो we call that solution as unsaturated solution. तो सैचुरेटेड सॉल्यूशन अनसैचुरेटेड को सैचुरेट बनने के लिए थोड़ा ही अमाउंट ऑफ सॉल्यूशन सॉलिड की ज़रूरत होती है. What would happen if you were to take a saturated solution at a certain temperature और cool it separately? क्या होगा? सैचुरेटेड सॉल्यूशन का हमने लिया और उसे कूल किया तो we can infer from the above activity that the different substances in a given solvent they have different solubility at the same temperature. Increase the temperature solubility increases, है ना. जैसे कि पहले वो अनसैचुरेटेड था, एक्स्ट्रा हमने सॉलिड ऐड किया तो अनएबल टू डिसॉल्व, बट व्हेन वी हीट इट अप इंक्रीज द टेम्परेचर exceeded by 5 degrees it got dissolved. So different temperature solubility may differ. The concentration of the solution is the amount or the mass or a volume of a solid present in a given amount, that is mass or a volume of a solution. So how do we confer the concentration of solution? That is the amount of solid present in a given solution is given amount of solution is the concentration. अगर ये हमें mathematically calculate करना है तो for that the expression is given and formula is there. We should know that formula. So mass by mass percentage of solution, मतलब जो solution है उसका कितने परसेंट वो solute present है. So to calculate that you have to take the ratio of mass of solute upon mass of solution which is multiplied by 100. So that is a percentage calculation. percentage calculation करने के लिए हमें multiply by 100 करना पड़ता है, बट किसे करना है? सोल्यूट के मास को लेना है डिवाइड बाय मास ऑफ सॉल्यूशन, मतलब सोल्यूट का मास डिवाइड बाय मास ऑफ सॉल्यूशन मल्टीप्लाई बाय 100. नाउ लेट्स सी मास बाय वॉल्यूम परसेंटेज ऑफ सॉल्यूशन. पहले मास बाय मास देखा, यार मास बाय वॉल्यूम तो कैसे लेना? बाय मीन्स डिवाइड, मास ऑफ सोल्यूट डिवाइड बाय वॉल्यूम ऑफ सॉल्यूशन मल्टीप्लाई बाय 100. नेक्स्ट इज वॉल्यूम बाय वॉल्यूम. तो हमें क्या करना है? ऊपर भी वॉल्यूम ऑफ सॉलिड लेना है और नीचे डिनोमिनेटर में वॉल्यूम ऑफ सॉल्यूशन लेना है मल्टीप्लाई बाय 100. दिस इक्वेशन और दिस फॉर्मूला इज वेरी इजी. मास बाय मास बाय वॉल्यूम और वॉल्यूम बाय वॉल्यूम परसेंटेजेस ऑफ सॉल्यूशन वी कैन कैलकुलेट. नाउ लेट्स मूव टुवर्ड्स द सॉल्व एग्जांपल. अ सॉल्यूशन कंटेन्स 40 ग्राम ऑफ कॉमन सॉल्ट. कितने हैं उसका वेट? 40 ग्राम. इन हाउ मच ग्राम ऑफ वाटर? 320 gram of water. Now you have to calculate the concentration in terms of mass by mass percentage of a solution. We know the formula. mass by mass का क्या है? mass of solid upon mass of solution multiplied by 100. So first we will write what is given. क्या क्या दिया है? See the solution for this or the answer for this example. Mass of solute that is salt is 40 gram. mass of solvent क्या है? यहाँ पे water solvent है, कितना है? 320 gram. तो मास ऑफ सॉल्यूशन कितना हुआ? सॉल्यूशन मीन्स व्हाट? सॉल्वेंट प्लस सोल्यूट और सोल्यूट प्लस सॉल्वेंट दोनों को ऐड करो, सोल्यूट और सॉल्वेंट के मास को. दैट इज 40 प्लस 320 ग्राम इज 360 ग्राम. सो वी गॉट मास ऑफ सॉल्यूशन. नाउ यूज द फॉर्मूला. मास बाय मास परसेंटेज ऑफ सॉल्यूशन इज मास ऑफ सोल्यूट अपॉन मास ऑफ सॉल्वेंट मल्टीप्लाई बाय 100. So now write out, put the values. We got 40 divided by 316 multiplied by 100. When we calculate this, we got the answer 11.1%. Now let us move to the next point, that is what is suspension. अब तक हमने solution देखा था where it was a homogeneous system, but when we talk about suspension, it is non-homogeneous system like those obtained by group C जो था ना activity 2.2 में. They got non-homogeneous system that we call suspension, in which solids they are dispersed in liquid and are called suspension. Means we can observe the solid which are present in the solvent or that solution we call as suspension. So we call the suspension is a heterogeneous mixture. Homogeneous के opposite है heterogeneous. So suspension is a heterogeneous mixture and which the solute particles do not dissolve. Solute उसमें dissolve होता ही नहीं, but it remains suspended throughout the bulk of the medium. जो medium है solvent है उसमें वो suspended रहेगा. It doesn't get completely dissolved, so it maintain its identity. And when we hold that suspension as it may settle down. Now let us move towards the properties of suspension. So let's move towards the properties of suspension. First is suspension is a heterogeneous mixture. The particles they are suspended, which can be seen with naked eye. The particles of the suspension scatter a beam of light passing through it and make it पार्ट्स विजिबल, जैसे कि पहले हमने सॉल्यूशन में देखा था, इट अनेबल टू स्कैटर द लाइट बिकॉज जो इवनली present the solute ware, but here they are suspended in the liquid. The solute particles settle down when suspension is kept undisturbed. अगर हमने सस्पेंशन ऐसे ले रखा तो क्या होगा, solute particles वो जो नीचे आ जाएंगे, it will settle it down. So the suspension is unstable. So solution की जो property है उसके opposite suspension की properties है. So we call them unstable. They can be separated from the mixture by the process of filtration. Filtration is simple process से we can separate solute from the solution. And when these particles settle down, we can get a clear liquid on the top. So through that that light cannot be scattered. जब suspended होते हैं particles तब light scattered हो जाते हैं, but they settle down this particle, light cannot be scattered. Topic is what is colloidal solution. So you must have your idea got clear about a colloidal solution. when the solute added into the solvent, it doesn't get completely dissolved, but it remains suspended. So the mixture obtained by the group B in the activity 2.2, it was a colloidal solution, or we also call it as colloid. The particles of the colloid, they are ununiformly spread throughout the solution. जो पार्टिकल्स होते हैं, सोल्यूट होते हैं, वो सॉल्यूशन में scattered रहते हैं due to the relatively smaller size of the particle as compared to that of the suspension. The mixture appears to be homogeneous. दिखने में हमें homogeneous लगता है क्योंकि जो particle size होते हैं बहुत कम होते हैं, but actually a colloidal solution is a heterogeneous mixture. For example, milk, when we add in milk में जो कुछ भी content added, it itself is a solution, right? So it is a colloidal. Because the small size of the colloidal particle, we cannot see them with naked eye, but this particle can easily scatter a beam of visible light as observed in activity 2.2. The scattering of a beam of light is called Tinder effect. So what is the Tinder effect? When we expose a beam of light on through the colloidal solution, it scattered the light. This light gets scattered, the beam of light gets scattered. We call it as Tinder effect. So you can see this Tyndall effect, it can be observed when a fine beam of light entered a room through a small hole. This happens due to the scattering of light by the particles of dust and smoke of air. You must have observed this. अगर छत है घर को और पूरे घर में अंधेरा है, and that roof is having small hole, through that when a sun ray is entered, you might have seen small dust particle moving in zigzag pattern. These are nothing but Tyndall effect. Let us stop here for the day. Your homework to write the differences between the solution, suspension and colloid.